So again, we're going to add and subtract some matrices now. Here it has to be entry by entry. Now that means they must be the same order, the same size, because I have to have an entry in each position to add or subtract. If they don't match up, they don't add. So our first one here is, given these pretty matrices here, A, B, and C, figure out A plus B, if possible. So when we look at A, I see my first row, and I have 3 entries, and then I look at B, and I have not 3 entries, not across. I do have 3 entries down, but not across. So here, A plus B cannot happen. Doesn't exist. Can't do it. And if they ask why, it's because the orders aren't the same. That B slash C is my because. Orders aren't equal. There. Now, B plus C and C minus B, the next two, those we actually can work out. So for B, just give me a sec to write these. And plus C all right. So we see I have 6 entries set up 3 rows by 2 columns. So these I can add or subtract on the next one. So we literally do this entry by entry. So I'm going to take my first position here, -8 plus 4. And then I'm going to write it over here. -8 plus 4 is -4. Just like that. So each sum, I'm going to put the result in the position for where I'm adding them. So our next one, 0 plus -5 is indeed -5. Then we have 1 and 12 is going to be 13. 5 and 3 is going to be 8. -4 and -2 will be -6. And then why a half plus 2? Because they could. So 2.5 is the same as 5 halves. There's no easy way to type a mixed numeral on a calculator, and there sure isn't an easy way to do it in the matrix menu. So go with the improper or the decimal. You could write 2.5 because this is a terminating decimal. But you can get the calculator to do this if it's not comfy for you. All right. Now we're going to do C minus B. So let me copy C first, because the order here is going to make a difference. Meaning C minus B is not the same as B minus C. All right. And now we just subtract entry by entry, but because we're subtracting, watch out for the signs changing. Subtracting is the same as adding the opposite. So I could just flip all the signs in B here and then add, but I'm just going to run through it. So 4 minus -8. That first row, first column, minus -8 becomes plus +8. So 4 plus 8 is a 12 now. -5 plus 0 is a -5. -5 minus 0, not plus. I said the wrong word. Still the same answer, but matters. 12 minus 1 is 11. 3 minus 5 is -2. -2 minus -4 becomes plus +4. -2 plus 4 is a +2 now. 2 minus 1/2, 2 wholes minus 1/2 leaves us with 3 halves. There's our result for C minus B. So on these, it would probably take you longer to type this in the calculator than just crunching each calculation by hand. So I'm not saying you have to do the mental math here, but choose whether or not you want to go through the effort of putting something in the calculator based on the problem. Because they're not going to keep the same matrices from problem to problem. They'll change them. Sometimes even within the same problem, poof, changes. All right. So just going to talk a little about properties here. So an additive inverse. When we think back to numbers, the additive inverse is what do I add to a number such that I get 0 as the result? So what number cancels out a number? So if I have 2, what do I have to add to 2 to get to 0? -2. If I have -3.7, I would have to add +3.7, so it cancels out to a 0. Matrices do the same thing. It's just we have to do that process for each entry. But that's literally all it is for finding the additive inverse. You just change the sign of all of them. And you will end up with a 0 matrix. Now, 0 matrices can be noted, and I know it's hard to see in the typesetting, but that's a slanted O as opposed to a straight up and down O. But basically, it's a matrix of an appropriate size where everything's zeros. So now that we've defined addition, the book formally puts out that matrix addition is commutative, same forwards and backwards. I can associate and still get the same thing. There are additive inverses, and there is an identity. Whee! If you have to take linear algebra, that's important. For the end of college algebra, Then we have what's called scalar multiplication. So scalar meaning we are multiplying by a scaling factor. So a scalar is just a number. So like in the example here, it is 5. So they had A, then they figured out what 5 times A, 5 times as big as A is, by multiplying each entry by 5. So when we say matrix multiplication, this is not matrix multiplication. This is scalar multiplication. That's taking a single number and multiplying everybody in the matrix by it. Now, scalar multiplication follows our normal familiar multiplication rules of real numbers. I can distribute the scalars either to 2 matrices, or I can distribute 2 scalars to the same matrix, and I can reassociate. So with those, this idea of scalar multiplication, now what we can do is start mixing it up and getting all crazy with it. So here I have 2 row matrices. They are the same dimension, so I can add and subtract, play with these just fine. And if I multiply them by a scalar, it's not going to change the dimensions, the order. It will still be a row with 3 entries, a 1 by 3. So that is what we're going to do. So we have -5 times A. Then we have -2 onto A plus B. So I'm going to figure out, let's start with A plus B, since that is the innermost thing. All right, so if I look up there, A plus B, 4 plus -2 is 2. -3 plus 0 is -3. 9 plus 3 is 12. So we figured out a plus b. Now I also need to figure out negative 5a and negative 2 times this thing, and then I'll add those two results. So since we're already on this one, I'll go ahead and do negative 2 multiplied to a plus b. Since I already added it, I just have to do negative 2 to this result. So multiplying negative 2 times 2 is negative 4. Negative 2 times negative 3 is a positive 6 now, and then a negative 24. Now, since I put the negative in there, I'm going to add this result to whatever negative 5a is. So let's go ahead and crunch through negative 5a now. So I just take my A matrix, everyone gets multiplied by negative 5. So now it's a negative 20, a positive 15, and a negative 45. All right. So now negative 5a is this crazy mess. Minus 2 onto a plus b is this crazy mess in blue. In order to calculate, I have negative 5a and minus 2 times that. Since I put the minus in here, I'm just going to add them. That would be equivalent. Alternatively, I could not multiply by negative 2, multiply by positive 2, and then I would subtract the matrices. Either way works, multiple ways to get to the answer. We could have even distributed the negative 2 and combined negative 5a and negative 2a to get negative 7a. Just yay, lots of stuff. So we're going to add these two. It's written like this. It's a little more straightforward. Negative 24, positive 21, and a whopping negative 69. All right, so that's basic addition, subtraction, and scalar multiplication with matrices. Now this means, we'll see it in a sec. Let me pause the video and then come back.